So we're going to look at this module here, which is called the secret module. The secrets module is one of the built-in modules in Python. So if I scroll down here, scroll up, this is from the Python module index, which is about 300 different modules that Python version 3.11 has. So if I just Control plus on it and go to secrets, there we go, that's the actual module. We found it, we click on it, and let's just have a look. Generate secure random numbers for managing secrets. And one question would be, why don't I just use a random module? So the secrets module here is used for generating cryptographically strong random numbers suitable for managing the passwords. But in particular, secrets should be used in preference to the default pseudo-random number generator in the random module, which is designed for modeling simulation and not security or cryptography. So that's kind of like the key difference between them. So let me just highlight that quickly, which is generating cryptographically strong random numbers. That's what the secrets module does, as opposed to this random module, which is designed for modeling simulation, not secure cryptography. That's kind of like the key difference between them over there. So let's continue and just have a look down below at what we've got here. So random numbers. So we will have kind of like seen this before in a way, but the secrets module provides access to the most secure randomness that your operating system provides. Now we have to do import secrets, and then we've got like secrets.random and so forth. So let's just have a look, and we'll go through all of these quickly. So I might pull this over to the side somewhere so that it's available, and we'll have a look from there. In fact, if I can put it over the side over here, that might be quite useful, although it will still be overwriting on certain stuff. But we'll have a go this way. So we're going to do, I've got an import of secrets already in there. It's a built-in module. And that means that we can start using all of the different methods, and we can see here that we can do secrets dot, and I guess we can see all of the different options. They're alphabetical at the moment, I think, until we actually invoke one and go to the top of our list. But these are the different methods that are available. So choice, compare, digest, random, below, random, etc. For each one will tell us what it does. And then there's a bunch of private like attributes are available as well, but we're not going to look at the private attributes. We're just interested in the functions. So let's do the first one, which was this random, I think it was it even ran below? I'm just wondering, or ran bits. Let's have a little check over here. Oh, system.random. Okay, fine. So let's see what that does. Secrets.system random. Okay, that is a class in itself. Right, a class for generating random numbers. Okay, fine. That's just that. But we can do secrets. I think we can just go straight to the dot choice. There we go. So let's just do the first one. In fact, I wonder if they will crop up alphabetically or not. But we got system.choice to start with. Choose a random element. I just wonder if we do the secrets dot system random dot. I wonder if you'll expose choice that way. It might be a bit clearer that way, actually. No, it does give us the same stuff anyway. So either or, whichever method that you want to do. This is a bit more long-winded, but I guess it shows where it comes from. But we've got this system.random and then a choice, and we can put in a sequence in there. It literally describes what actually goes in here. So over here, choose a, well, it says here, I wonder if it is, choose a random element from a non-empty sequence. So what is a non-empty sequence? A sequence is something like a list. So let's just call, I always used to use the word list, but actually we'll call it a sequence. Seq, there we go, equals. And then like 1, 2, 3, let's face 3, 4, and 5, and 6, there we go. So sequence, and we'll put something like result is equal to that, And what we might do actually is we'll put it into def, or we'll create another function, test. We'll call it test secrets. We'll make a few different functions possibly. So let's just do that, and we will then move all of this code down below, because we might build up and check various different things. So in fact we will return the result like that. There we go. So a nice little concise bit of code, and we can call this function that we've just created, so test secrets 01. So we just run our little function over here, and in fact we don't even, well, okay, our new result is equal to this, and then we can print out the result just like that, and we should just get a random number. So let's just hit F5 to run it. In fact, I'll hit clear over here, and I might even get rid of, because I'll do a Control J and I'll run it in the interpreter. So Control J, that Control J just toggles this on and off, the toggles the terminal on and off, and I can then do control return and run it in the interactive, because it's just a little bit clearer to do it. The interactive is just launching down below over here, over this little section. It looks like it's launched. Get a type error, missing one. Okay, let's have a look. Random.choice, missing one required positional argument. Interesting. Line number 29. Ah, of course, secrets 01, R1. Maybe we can't call it like this, and maybe we do have to do, I just wonder if that will work. So just do a control return. Yes, it does. Okay, and we're going to keep getting random numbers. So I couldn't put in just the sequence, not the sequence. So just to reiterate over on the code here, that's the actual class itself by the looks of it, and these are the actual functions. So that's how we call it, which is actually how I always call it. I just wonder if I do open this as a new tab and see how that is. So we just take those. I guess the classes are actually just exposed. Let's have a, because all of the examples are there, we never get the import thing, but basically this is how it's done from other pieces of code that I would have taken out of the web, which is basically import the secrets module and just do secrets and then dots, and that will expose all of the methods. So that's perfectly fine enough. Alternate random number generator, because this is going to return you a class, and then that class will return something. Okay, now let's say we want to just get, I guess, a few more random numbers. We might do something like this, which is for I in range. We'll actually do the for loop there. Let's create 10 random numbers out of our list of 6 only, so it's nearly like we're rolling a dice actually. And then our result is this, and we could actually not just return a result, but maybe we'll return an array. So I could do this in list comprehension, but at the moment we're going to do it like this, which is we will, instead of returning just one, we're now going to return an array. So we will do something like this, which is results.append, and then we will put all of our secrets in there like this, so something like that, and then this will return back a result over here, and we will get a result which is an array this time. So this should return back a, we see here it returns back, if I can hover over it right, returns back a list, and then our list will print it out. So let me just get rid of this one because it was like the error message, don't like seeing that over there, and then hit control return to run it again, and now we get a list of random numbers which could be dice rolls. So we could do something like this, which is print. Yeah, we could actually put it straight above. We could do print dice rolls. There we go, and that's our dice rolls over there. So that's our first version of it. Let's pull out other stuff that we can do with the secrets module. And I wonder, I'm going to navigate backwards on this. Well, actually, I don't have to navigate backwards. I've got the tab over there. I wonder if it's choice, and then we've got random below and random bits. Return a random number in the range 0 to n. And this thing here, this curly bracket, this parentheses, a closing parentheses, means, I believe that means it's not inclusive. So it's not an error in the typing. It means that this is not inclusive. So it goes to n minus 1, effectively, is what it's telling us. So let's just do this anyway. We can take, I guess we can take part of this back out, and then so like we'll call this function test secrets 02. And then we will have, it won't be a sequence, but what we'll actually clear this all out and just maybe return a result only. And what will this result actually be? So our result will be equal to the secrets dot, and then we're going to go with the rand below. It says exclusive upper bound over there, and if I so open brackets, we'll start with a 0 just to show, but that's the upper bound. And I think that would have been the lower bound. Funnily enough, the doc string is, I wonder if the doc string isn't intuitive enough there, because the first item should be the lower bound and then the other item should be the upper bound. So, oh, it just says exclusive upper bound, I guess. So you could put in one number. I presume that, yeah, you could actually do it with the keyword itself, exclusive upper bound. But I just wonder if, like, for example, we did 100. That would mean the upper bound is 99. So there's a few different ways of doing it. There isn't a mention of the lower bound per se, as far as we know. And in fact, I guess if I go to, again, pull this over here, secrets.rand below, there isn't actually, I wonder if there's a rand below that, apart from this one here. F. No, it's the only occurrence of that on the page, so we have to infer what it actually means, but we can do this inference anyway. So, or we can play around with it, like what might this infer. So now we are going to do print something like, print random number, and basically let's put a colon there, and basically our random number now is going to be R equals, and then test. Again, we're going to test it, sequence this underscore 02 this time, so we're going to run this function, and we'll actually call this, just let me know, gen a random number, which we could have used random module, but we were told that this random number works. This is for a cryptographic random number as opposed to a random number that might be used in a simulation. And here is get a list, simulate a dice roll. I don't know if I spelled roll right, if it's R-O-L-E or R-O-L-L. And that should be it. We'll get a random number, and this time we can do a print of our, let's just copy all of this over here, copy that and paste it straight down here, so we've got a print of the result. And if we just run this now, we should get a, I didn't mean to do it like this, but anyway, just as well, because it throw us an error. One positional argument, but 2 were given. Okay, good. This error was quite descriptive in telling us what it is. It's a bit of a shame that sometimes, well, maybe I should have followed the docs actually. It's only expecting one thing back. So it's only expecting the exclusive upper bound. I should have understood the documents. As in, when this came about, there was only one argument. That means it was only one argument. It wasn't 2. This 0 is automatically implied, so we're only talking about this integer n part that goes in here. So I should just be putting in the 100 and nothing else, and that should work. So I'm going to toggle this off. I didn't mean to hit the F5, but so Control J just to get rid of it, and we'll run it in the sidebar over here we're going to run it in this section over here by doing control return in VS Code, and we get this random number that pops up here. And again, we could do something like, I guess, let's just make this a little bit lower. So we'll make it up to, say, for example, 6 again. And in fact, maybe we'll actually steal some of this code, because there's still loads of this code. There we go. Oops, not that. We can tab this in, because we will do the same thing, which is dot append, and then open brackets for the append, and there we go. We can put our random numbers in. Now we're going to get 2 arrays that come out. One's for our one's for we passed in a list, and the other one here is actually for when we've selected list. But notice one thing, this says 6, and I think we'll see this, but we'll never get a 6 because it goes from 0. It was going to go from 0 to 5. So we're just going to run that, and we see here that we don't get a number that's above 6. And like, we could keep running this to actually test it. So let's just make this like 50, for example. We're just to sort of like show it. We definitely got a 6 by now, unless we had really bad luck. So this is exclusive. So again, I'll go 0 to 10. If we wanted to have a 6 in there, we would have to go to a 7. So 7. So something like that. But funnily enough, there's no argument in this secrets.rand below that lets us have a lower bound. So unlike the random module where we have rand.randint, so if I was to do import random, and then I do something like random.randint over here, we can actually specify, and that's why I thought that the secrets module was work. We could specify a lower bound and an upper bound. The secrets module, at least for the purpose of selecting a random number, doesn't do that one. It's just got this rand below. So that's how that one works. Now let's do another one. I might actually copy all of this and paste it over here, but this will be a version 3, which is generate random bits. Don't even know what this one does yet, although we can read the module. We're going to loop through again via range 10, and we're going to let's just do this. I'm going to take the random bits, which is just going to show that we got rand, and then we got rand below and rand bits. Generates an integer with k random bits. Okay, so that's our rand bits over here. And maybe this time actually I don't want to stick it into a for loop, funny enough, so I might not have needed to do. And I'll just go back here and then do a result. Instead of result.append, we'll just do result equals, only because this random bits is going to be a bit larger, I think. And what do we need to put in there? We have to just say how many bits that we want. So let's just say it's 5 bits, and then we want to control this. So let's just do this. Copy that and paste it over here. Random bits, and this will come from our 3rd tested module over here. So run that piece of code, and we get random bits, and that's 15 there. Now, I guess that 5 means 5 bits, which is, I wonder if that's 5 bits. Like, that goes up, makes number up to 5. I'm just wondering if it's a number up to 5. Let's just make that a bit larger. So let's make that 50, for example. I just think this, does this number get, that's got 50 bits. How many, I should ask the question, how many bits are there in a byte, I guess. Let's have a look here. So I'm going to go to Claude AI, because I think there's 8 bits in a byte, but how many bits in a byte? There's 8 bits in a byte. I wonder if we get some sort of example, but 8 bits in a byte. That's how many bits there are. Random bits. That probably, if we do one, I think we'll only get like 1 byte. But we see that I wonder if I restrict it again and just run it a few times. Maybe I should put it in a for loop. We're always going to get a small number basically with 5, and then we get bigger numbers. Like if we do put in like 50 there. So again, maybe I should have done this because it's just nice to see that. I wonder, because we're just going to get these long arrays otherwise. So it swings and roundabouts with all of this stuff. Because if I do 5 and hit like run it like that, then we just get a whole bunch of numbers over there, which is 5 bits basically. I could have used anything. So like let's just do 1 bit because that's smaller. We're going to get randomness between 0 and 1. I wonder if we do 2 bits, what's that going to give us? Okay. Yes, so the bits are, if I'm reminding myself, this is just by like extrapolation, but it goes something like the first one represents a 0 or a 1, and the next one represents a 2, and then the next one represents a 4. So I think if we do 3 bits, so if we do 1 bit, it's going to give us 0s and 1s. If we do 2 bits, then we can have up to a 2 plus a 1, which is a 3. And if we do 3 bits, we can have a 4 plus a 2 plus a 1. So I think that the most we can get there is 7. So that's just a reminder of what that is. So if I do 3, yeah, there we go. So like most we'll ever get is a 7 up to there. Maybe it's even a 7 minus 1 by the looks of it. No, we can get 7s up to there, and so forth. So that's what it is. So that will be, the next one will be 8. So it's building things from standard binary numbers basically. I'm reminding myself of old school time, like from literally GCSE level, for when you were like 12, 13, 14 years old, when you kind of like start learning that. That's what that is. Now let's move across, because there's extra things to go in here, which is the generating tokens. So token underscore bytes. Return a random byte string containing n bytes. Number of bytes. Okay. If n bytes is none or not supplied, a reasonable default is used. Okay, that's an interesting one, because I don't know what a reasonable default actually entails, but let's just do that. So we'll copy this again and paste this over here, and I might actually save this actual module, the entire module, and into GitHub and provide a link to it if anyone cares for that. They can do that. So I might actually take some of this as well. So this is a random byte string. So generate a random byte string. That's what we're attempting to do. And this time we are going to use the, get rid of this. Secrets, and then we're going to do token bytes like this, and we can see here that it says again, like, is this documentation clear or not? Not 100% sure. Let's have a little read. Return a random byte string containing n bytes. Okay, it's the same as the docs that we saw, I think. If n bytes is none, or not supplied, it will return a reasonable amount. Let's just use the default because it's had 16 in there, so we'll do 16 bytes in there. So token bytes, tab, and then 16, and then we're going to return this result, and for in range, say 2, I guess, because 2 not 12, because we're going to return like some long stuff, I guess, that comes back. So copy this again and paste it over here. That's for our third test, and it's going to be secret, so 4, and we're just going to generate a random byte string. So we just call it something like, there we go, and that will be module 4, and we can sort of like see just from our little doc string random byte string there, and we can do a run of it, and we see down below that we get these 2 things are a little bit longer in. So what I should actually do is, I wonder if I can do the import. I wonder if it will do this pprint, and then maybe we can do a pprint.pp. I wonder if that will be clearer in here. Yeah, it does. It breaks it down. And we can see here both elements of the, because we made our list only too long down below, we could have made it a bit longer. Let's make it a bit longer now. So say 5, for example. Make it even 6. There we go. Keep on making them. And that's got nothing to do with it. Actually, let's just make it 5 long. Run. There we go. So we get these random byte strings over here. And this p print just organized it a little bit nicer. That's all it really did. And actually, I wonder if I can do like depth or indent. Okay. Over here, indent 4. There we go. I wonder if that's a little bit clearer on our running. There we go. It does a little indentation for us. I don't know if it's clear or not. But here we've got this stuff, and over here we've got B, and I think this B is, or not think, this means that what's returned is a bytes string, and then if we wanted to convert it, byte strings are supposedly more efficient for the purpose of transfer of information than regular strings. We can convert a byte string into a regular string in Python. Anyway, we move on because the next one is actually the token hex. So I guess we can take all of this again, and this is going to be quite similar. We'll turn our function into a 5 this time. Actually, it's a random text string, so that's a bit better. Random. So I just turn this word into text. So we're now going to return back a random text string, and the way to do that is token hex. Funnily enough, like return a random text string in hexadecimal. Okay, so then it's got a URL safe one as well. So we'll do all of them. So the same thing. If there's none, then it's going to pick something automatically for us that's suitable. I don't know like what the suitability is. We'd have to look even further into the docs in some way or discover that. So let's just have a look at that and see how that one works. And I'm just going to over here hit the so yeah, one more thing to do is not forget to take all of this and paste it over here, and this time we are going to return a random text string as hex. So hexadecimals, there we go. And we're going to change our thing over here to be 5, and we can see now that we're going to generate a random text string because we put our documentation. So it's all nice and clean. So for the sequence module, let's just run that, and here we now get, so if you don't like a byte string, I hate using byte stuff because you have to convert them back, and then I forget to convert them, and I have to remind myself, and it gives me all these various errors. If you're doing like big data stuff, I think the bytes thing's more efficient, but I just find the text string much easier because it's easier to comprehend. Here's our random text string. I'm not sure. I wonder if the 16 means actual 16 characters. I don't think it does. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe it's 16 hexadecimals. I don't know. Because these all seem to be of the same length, let's just test it by making it a bit longer and see if any of them. We'll go to 20. There we go. Let's just run that. Let's put the dots in between, but they all seem to be the same length, so it's a fixed length at least. So there we go. Make it a bit smaller so it all fits on the one thing here. So that's the generating random text string. Let's see what our next one is. We've got one here that's actually called the URL safe. Return a random URL safe text string containing n bytes. So okay. Base 64 encoded, so on average each byte results in approximately 1.3 characters. There we go. If n bytes or is none or not supplied, a reasonable default is used. Okay, how should it be used? We've got these use cases in here. Here's an example for creating passwords down below, but we're just going to do this token URL safe one here. So let's just have a little go and try it out. So we'll do the same thing, copy this and we'll paste it over here, and we're just going to make our range a little bit smaller, so 5, and here we'll make the range again 5, and we're just going to change our function to number 6, and this is going to be a URL safe text string. So generate URL safe text string, and we only need to change over here dot token have a putting a dot in here, token, and then URL. So if this is only the only other option that's available, and again we can put in whatever we want. Let's stick in 16 because I think 16 is still in the defaults, and we can then go to the top of the code and copy all the same stuff and rerun that, which means that we'd have to make this a 6 over here, which is the URL safe string, and just could actually paste that straight into here like that, and that should be sufficient for everything to now run. And we see over there we get our URL safe strings. I don't fully know what URL safe string is, but I presume it's good enough to be inside a URL command of some type. And that kind of like takes us to the end. So everything seems to work there. It all seems to work nice. This is we are told that we get this extra piece of randomness that's a bit more secure than just using the random numbers. So that's Python's secrets module, and I think that's it. If there's any questions or any comments that anyone would like to put in, definitely put them in. If you like this video, do a thumbs up, follow the channel, and even if you don't like it, still put your thumbs up and still still follow the channel. And thanks a lot for listening. I think that's it.